Today we are going to talk about the Feldspar diagram, how to read it, and how to interpret the information it provides. The Feldspar group is a solid solution group. A solid solution occurs only in minerals that share the same crystal structure but have different chemical compositions, which may result in different physical and chemical properties due to these variations. What does this mean? We can imagine a crystal lattice where several components are stacked together, like many small spheres, and there are empty spaces where spheres of similar size can fit. This is the case for calcium and sodium, which defines the Plagioclase Feldspar group. Along the Plagioclase series, there is a gradual substitution of calcium by sodium because they have very similar ionic radii, allowing them to occupy the same structural sites in the crystal lattice. However, this substitution creates a charge imbalance since sodium has a +1 charge and calcium has a +2 charge. To restore electrical balance, there is a coupled substitution of silicon by aluminum. Silicon +2 is present, aluminum +3 tends to be present, always seeking structural and electrical stability. In contrast, in the case of calcium and potassium, a gradual substitution does not occur because potassium has a much larger ionic radius than calcium. As a result, they cannot occupy the same structural sites. So how do we read this diagram? It is important to remember that the end members are not always positioned in the same orientation, and that the end member closest to a composition indicates a higher proportion of that component. For example, the closer a composition is to the calcium-rich end member, the higher the calcium content, meaning a higher anorthite component. Likewise, the closer it is to the albite end member, the higher the albite content. This is important because we tend to read diagrams from left to right, and this diagram does not always follow that convention. Plagioclase feldspars are classified based on their anorthite An content. The classification is albite, oligoclase, andesine, labradorite, bitaunite, and anorthite, ranging from the most sodium-rich to the most calcium-rich end member.